Hey guys, welcome back to the channel. I have another Marine ECM test, this time coming from New York, Paragon Marine. Jake, he sent me a computer. They are repeat customers. They have trust my Salazar Diagnostics in the past, and they send this computer now to be tested, and actually also the engine harness, which I'm going to show you in a second. I have a note in here from Jake. He said, Mike, I sent you a harness from a 350 MPI with a MERC 3 ECM included in the box. A customer hooked up his battery backwards 2 years ago and cooked the ECM. We got a used ECM from Bob in California from Murphy Burns, and this boat has not run. Correctly. We have replaced most sensors as they were bad or reading incorrectly. Here is some data for values we're seeing. So they send me incorrect, or readings that were captured on DIACOM or whatever diagnostics they were using. So I am being running the computer, as you will see in a second. So let me make sure the intro is off, because sometimes it goes automatically in here. All right, so everything should be good. Let me take you over to the display. All right, so, well, since we land in here, let me just get you a little commercial. If you have any computers that you need to send to repair instrument clusters, just look for MikeSalazarDiagnostics.com. Yes, my name is spelled M-A-I-C, as in the picture right now or in the screen. And this is the land page. This is a home page where you will get into my website. This white box that I have here, right in the middle, I'm moving a red little hint in there. You can use that for a generic module that anything that you are sent. You don't need to go into that list of normal or common repairs that I have down for if you have a Rialta instrument cluster, a 4-line, and if you scroll down, you will see that we have more of the more common repairs. I'm trying to make it as easy as possible for any customers. If you click on this Y form, you don't need to scroll down. This will be a form that you need to fill with your information, the serial number, the bin, and etc. And then you can send me the module. The order box that we have right here on the right, that says click here to email us, is as it says, right? So you click in there, your email browser or application in your phone will open up and you can send me an email. I have the address where you can ship the box and make sure that you fill that form and add it in the box. I also have this button that will scroll or be along the website. Is the chat. And that chat, if you are typing something and I don't respond immediately because let's say I'm away off the desk or I'm driving or something, right? Make sure that you leave yourself an email or a telephone that I can contact you. All right. Okay, go back to the repair. I have Rinda DIACOM running for 27.35 minutes. This computer, when it came, which I have the folder here, I have also take pictures of what I've been finding. I can also show you that it is indeed a correct calibration. That yellow line, the second one down, let me take the circle out because you're not seeing everything, is the correct calibration. D5CE. It is a 5.7, so that is correct. All right, so that is a correct calibration, and that's what I have in here, just to confirm that everything is correct. I always connect the computer. I don't touch any of my values on the simulator just to see if sometimes I have a overheating temperature, and I don't touch it because I want to make sure that before I print this, I can compare the values and make sure that this happened on my hands or that was something that came with the computer. All right, so as we see, if you scroll down in here, temperature 158, so that is normal. Air temperature, not sure why it's not, okay, yeah. Manifold air temperature, 85. Going into the calibration, let me see the checksum right here. So D5CE, that's what we compare. And then just scrolling down, because it's all that rest information is what I have. So the fault codes that were here were these two. Throttle position sensor voltage low and manifold pressure sensor voltage low. So I have performed a full test on this computer and in the harness as well. The way that I test the harness is each pin on the harness, I do first, a non reading continuity test and a load test. How do I do a load test? I put usually a high load. I have multiple things that I use, like a high beam. That's actually really good. I got a tool that I will show you in another video probably, that is actually the pulsar, that is really good because you can select multiple different loads up to 100 amps if you want. So this is really, really good. But yeah, so I use that one, and I check if each point, each terminal on the harness. Let me just show you 1 second and I'll be right back. What I'm talking about, because this is as far as Jake has gone because of what it was, you know, they were trying to correct. So yes, look, I had the complete engine harness in here. I checked all connections. There is no corrosion. There is no burn. That they do have now to fix a couple of the connectors that they cut. There is a one in the coil that is, let me just see if I find it. There's a couple of terminals they're going to have to fix, but nothing that is really that bad. Let me see if I find it. Yeah, right here. So one of these terminals broken, but yeah, as you see, this is all heat shrink with, you know, heat tubing shrink. I'm sorry, I was looking to the wrong direction. But yeah, those are not corroded. Not even the eyelids are corroded, but so I load test each of these first with continuity to find exactly, they make sure they are in the correct pin, going onto the wire diagram, and everything tested out good. There's absolutely no damage in here. Why they did this? Let me put it back away. The reason they have done all these homework, well, first, because a battery was connected backwards, right? Secondly, because, you know, they've been dealing with a company that is not honest. And I have to say that because if I sell something to you and it's not working properly, I cannot make you go and spend hours and hours and hours trying to find a rabbit hole that it doesn't exist. And this is exactly what they've been chasing in here. They should have, like, you know, or he should have that company refund the money if he doesn't have a computer, or tell him the truth. You know, let me send it back to me. Let me recheck and make sure everything is fine. And be honest. The reason I say things like this is because I do take the time. I do charge for, you know, a harness test like this one is hours of testing. So it is definitely, it's going to be an expensive test, right? Because it's already an expensive test for the customer. Why? Because to get the harness out of the boat, I'm not sure if they have to pull the engine out or how they did it, but I don't think it's any easy task to do. So it is already an ongoing add-in testing because they're trusting a not trustful company. All right, going into the display. Right there. Okay, as you see, I have the computer running. It has been running for 32, almost 33 minutes. Right now I'm in idle. All right, guys, I'm back. Something happened and the computer crashed and I have to restart everything. But luckily for me, and I'm using OBS for this, and I didn't lose all the footage. This is the good thing about recording on MK something. It's like they name. And let me show you. I can go into the display. Yeah, so this is what I'm actually want to show you. When you're in here, I can remove, or that's what they call removes the recordings, and they are saved as a .mkb. If you save in OBS the files as mkb, they will not. You can actually, it will shut down as soon as, if anything happens to your recordings, to you lost power or something, you can close that and save it. Then when you removes an OBS data for you, save it as a MP4, and that's what I do. All right, guys. So let me take this out of the screen in here. Make sure that we are recording. Okay, we are. So as I was saying, I've been doing the test for now this time 38.33 minutes, and I can definitely see the problems on the computer. So let me stop, and I wanted to do this on the video. Let me stop these here because in order to run a recording, like in Diacom, you can record all the files for as long as you want, as long as you have memory on your computer too, right? So that's what I have done. You can do now onto the files, and to record live data, just click on that little camera that you see there on when I'm moving that pointer. But now to open records, you just go into that folder. On top of that, I'm going to click that, and yes, this is the last one, the record values in here. And I hope I got more record data. Let me just see once. Well, I can check that outside the video, because I should have tons of more information. I transferred. This is a new computer that I'm using now, and I still got my old one, which I'm sending over to my daughter in Costa Rica. But I haven't sent because of the same situation. I want to make sure that I got everything in here, even though I save everything into a hard drive, a solid state drive that I can always revisit. I want to make sure that everything is working 100% before I'm send that one, because that's an Alienware Aurora R13, and now I have the R16, which is the latest and greatest. But yes, this, and I have never crashed on the Aurora R13. I have never had a crash ever, and this is the first time I do. But I just also updated OBS, so I'm not sure what happened there. All right, so but yeah, so we click on here, and then now we open the file. We can now do the complete recording, which, as you can see, I recorded for a long time. And I went over, and this is the nice thing about Diacom. Diacom will even, it's always recording. I think it's like a 3 minutes or so that records. It keeps always the warfare recorded, and it will say the last 3 minutes. So even if you start the recording now, 3 minutes or a minute, again, I'm just doing a guesstimate, right? Will be there for you even before you click the record. And this is very nice. So as you see right there, I am in 600 and something RPMs, and you can play the capture, and it's definitely a little faster. You can see that this is too fast, because you cannot really see much. But even though I want you to see this, because, okay, right now I'm in idle. Okay, the IAC position is in 150 steps. So that is, let's say, okay, right? The throttle is really glitchy, and I'm going to show you that in a second. Just want to show you what I see here. The map value is also very glitchy. All the values are like 3 or 4 values in there. As you see, the temperature is changing from 158 to 162 by itself, and I'm not touching anything. Same thing as the idle, the throttle position, and other values are changing by itself, like the spark advance, because of that glitch. Right now, okay, well, let me go back a little bit, because right now I'm in, all right, so 600, I went from 600 to 2000 RPMs. I'm going to stop this 1 second, because I just went from 600 or 700 RPMs to 2000. I look at the IAC position, it didn't change. That is already a red flag for me. Why? Because the IAC is a very important component on these engines, because that controls the acceleration and a lot of stuff that it needs to be correct, right? All right, so I'm going to go back. I want you to see, well, right here, the IAC, I cannot really, let me see, can I put some glasses? Maybe can. Oh, yes, I can. I have not used this much on videos that I don't remember. Okay, we got the IAC. I'm going to select the throttle position. I'm going to select the spark advance, the map manifold air pressure, and then on last, I'm just going to put in there so we can all see the engine RPMs. Well, maybe not on last, because right now we got 0 trouble codes. But when I went down to idle, just minimize it. I can do a little smaller. That is just a 0. Put it right here. All right, so so we got 2000 RPM, 34 degrees of a spark advance. So I'm going to go back to 653 RPMs. That's what we have. And we got 5.1% degrees of spark advance. So that is a very important values. And the spark advance is going to change depending on how much throttle you have, manifold air pressure. The IAC should also follow, the calibration should also follow that as you accelerate. And the IAC needs to change. It cannot be always 150 steps for me, that is fully open. And I might be wrong, but I did see the IAC, and I can see and I'll show you in a second when we go back to the actual live condition that I still have run the computer. I have not stopped it. What we see there. But so let's follow those values. So we have 2000 RPMs now. We got, I still got to raise it right there. So 13.6, and I'm trying to get to 13.5, which is, I do idle at 12.5 manifold pressure, 2000 at 13.5, 3000 at 14.5, and so on. You see what I'm trying to do? I'm trying to duplicate and always use the same value. So when I see something that catches my attention, I can remember, okay, well, this is what I use across the board. I can reproduce that and then see if how this computer reacts based on multiple, thousands of tests that I have done. All right, so again, throttle in 19%, IAC in the same position. I'm going to go over to 3000 RPM. Right now we are in 3000 RPMs, 14.5 manifold air pressure, spark advance change, throttle position change, IAC did not change. All right, so I'm going now to 4000. We are now in manifold or 15.5, spark advance change, throttle position, I change it, right? And the IAC didn't change. So I'm going now down to 3000 again. The IAC stayed in the same thing. I will change the manifold pressure eventually here, but so nothing. The IAC stays on the same. I want you also to see, right? So we got 0 fault codes, and then I went from 0 fault codes to 1 fault code by itself. So this time, I'm going to move this way. I wish I can. Okay, I can change the speed. Let me change the speed. And I want you to see that. That's actually almost, let me go over to 40 milliseconds. That's almost what I saw on this computer on real time. Look at the glitch that I have. I'm going to go back a little so we can all see that. I want you to see the glitch that I'm seeing on the RPMs, on the manifold air pressure, spark advance, throttle position. It's a glitch that is happening by itself. I'm not touching anything. As you see them, like, let's say in there, I was completely by itself. And this computer is glitching and glitching and glitching and glitching and glitching. Of course, this is going to create a huge problems on the boat. I mean, the RPMs are dropping constantly. It's like a continuous glitch. Right now, like, let's see when that throttle code comes in. This is what is so important to gather data. I'm not doing a guesstimate. This is data, collecting data, doing the test on the boat, doing that same thing. It's something you can always revisit and then analyze and then take your own determinations on what it needs to be corrected or not. And this is what I'm trying to show. Let me take the circle out. Because, yeah, you probably didn't see, but yeah, believe me, the 150 never changed. So we just got the code. Let me just go back because I missed that time. All right, so almost right there. No, that's already there. So yeah, that fault that we have there is for throttle position circuit high. Like, I'm going to like go back. It's very hard to do. Like, let me see. I wish I had more controls in here to go a one frame at a time, because I can change the speed here. And that was now going really, really slow. So as you can see, it is changing, but it's going really, really slow because I want to change exactly when that glitch happens. So you can see, look at the changes that we have as far as RPMs, as far as manifold pressure, and as far as throttle position, 11.5. I'm in 12.5. See 12.1. Oh, right there. So I didn't do anything. This is the computer by itself. So I went from 20% to 6% throttle by itself. Or am I changing something? Let me just follow a little bit more. because I want to see where I am. You see? Nope. Right there. That's the glitch. This is the beauty about a software like this. That glitch is the same computer. It's nothing I can do with this. I mean, as far as repairing the computer, yes, I can. But this is a computer they bought from Mephi Byrne or Bob in California. So if I open this computer, he's most likely going to reject his warranty. So at least this is a test that I can show Jake and Pargo Marine and tell them, yeah, the computer is a problem, 100%. There's nothing I can do. I mean, again, I can repair it, but will he accept it? Because is he going to refund the money to the customer? This is a thing that I need to now discuss with Paragon Marine and then see how they want to proceed, because I'm not Bob client. My client is Paragon Marine. So if they tell me, don't worry about it, just fix the computer, I will open it up and try to fix it. Because again, I don't know until I open up what am I dealing with. But I don't want to open it up because I don't want to void a warranty, right? If it's any, from that company. But yeah, you see the beauty of this test in here, how beautiful is that I can see the moment the problem happened. I'm going back again, and I slow down the capture so much that you guys now can see how this is changing by itself. Boom, it went to 6.3 by itself. And it went back to 20%. That is what, like 18% throttle change with you doing nothing. Think about how much has been this, or Jake or this company chasing a rabbit hole that doesn't exist because it's the computer, because they're trusting somebody else. And this is, it's very hard in the automotive and the marine industry and anywhere when you don't have one to use as a test. Why? Because if you wouldn't have a computer I can connect it in there, I can connect it and it might correct the thing, right? But if I plug a good computer and it's a problem in the harness and now I damage another computer, you see, this is where us technicians in the field are tied to, and this is where you have to be honest with your customers and tell, it's like, look, like I think they follow a correct route, which is do this and send it to me so I can, with all possession and truthfulness, tell them, yes, your harness is good, your computer is bad. Now he can go back and connect the harness and connect any computer and trust that there's nothing going to happen in there. Why? Because I checked it. I personally checked it and I know it's good. But this computer needs to be fixed. All right, so let me close all this to go back to the running values, because even though I stopped the communication and I'm going to have to close the software, it's just, I don't know, maybe I have to do something else on here. But when you select the folder and you go to the recordings, this upper menus goes away. So for me, I just do it over like this. I select again, MEPI 1 to 4, detecting the module, mode 1, and then I connect to the computer. As you can see, we're now running this for 52 minutes and almost 53 minutes. And when the computer came here, I got like 50.55 hours. As you can see, it has only 1.4 hours. So I've been running almost 1 hour of a test. So the clock in that is okay. I don't see right now super glitchy computer. It's getting a little better, because now you can see, and I'm going to put a zoom glass in here, but we can definitely see the glitch is still happening. And this is going to be more pronounced as I touch the throttle. So throttle right here. I'm going to select these bits, the most important ones. So you can see how that manifold pressure is changing. I'm going to put that one in there and then get the RPMs in here. I'm making it as big as possible so you guys can see. I'm out of the view. Let me actually move this here and this here and put the circle back, because I want to be part of it too, right? What else should we put in here? So we got manifold, throttle, spark advance, coolant temperature, engine speed, I still got the one fold code in there, which you still can see all the values on the back, and we don't really care that. Maybe the injection millisecond. Let me take a look at that. All right, so now I'm going to do that test a little faster than I normally do, but I'm going to show you. First, I always do is raise the RPM. So we are in 700 RPMs. I want to go over to 2000. One thing that we don't have in here, I forgot, is the IAC, right? That's the most important one. Yeah, so let me select that one in here, right? So that's the one common denominator that is not changing in here. So let me go back. Let me go up to 2000. Again, this is live data. I'm trying to get closer. I came to 2000, but it's very glitchy. I'm going to move the throttle to 20%. And as you see, this is, that is the sweet spot, the worst. I'm going to go from 12.5 on the map to 13.5 if I can. But as you can see, it's so glitchy. This is very hard to keep into one spot. You can see now the coolant temperature is glitchy. The injection millisecond is glitchy. The spark advance, a little glitchy, not so bad. But yeah, the throttle is changing up and down and up and down and up and down. So why is the IAC not changing? I don't know. It should have changed. The desired IAC, which is also, we should probably put that in here because this is also what the computer wants. So I'm not sure what this calibration that Bob might have put in here is doing. And I can tell you that, yes, I have seen computers that he has worked on where he changes parameters, and he can because he's a tuner, right? Change parameters, trying to mask glitches like this and make a computer somehow run, right? Because if you keep an IAC, let's say, if your 150 is fully closed, this might be a way for him to, mask this glitch because it's not opening, closing, and opening, closing the IAC. So I'm just, again, doing just a guesstimate. All right, but yeah, so you see 2000, all the glitch. Let's go to 3000. All right, so I'm going to go over a throttle of 30%. And you can see the glitchiness in there. I'm going to 14.5. And this time I was able to catch it. I noticed also that the higher the RPM, the less glitch it actually shows. So yeah, the desire and the position of the IAC are matching. So this looks like he did something with the calibration. Not sure. I'm going to have to look into my database, try to match that calibration and see if I have a running recording that I can compare to it. But why would you have an IAC in there if it's always in the same position, no matter what RPM you have? This is definitely, for me, something that is not correct. But let's keep doing the test. All right, so we got 3000. Let's go over to 4000. Too much. All right, so I'm going to go to 40% on the throttle. And then 15.5 on the map. But yes, we can see that glitch happening and still on the higher RPMs. You see, it's right now hard to catch by the naked eye, but we're talking about maybe 50 to 60 RPMs drop and up. Think about, this will be like, so hard to keep up with this boat because the boat RPM is going to change how much your boat is going up and down. The spark advance, at least at these RPMs, are steady. Manifold air pressure is somehow a little steady. Throttle, definitely not. Coolant temperature, a little glitchy. And I always believe in this. As long as your spark advance and your injector pulse width is not so glitchy, the boat will try to stay there. Not sure, if this glitch will be more on the needle than on the boat, because if you have 2.9 milliseconds of injection, and then 37.9 of a spark advance, that's what you're giving to your spark, and that's what you're giving to injectors. As long as it's not going, well, now I can see it on the injector pulse. And this is probably what we cannot see here because it's happening so quickly, right? That the computer is seeing it, but the software, which is just again the process data that is giving us is not really in real time. In real time will be what the computer sees. So if I will be connected to the injectors, which I honestly don't like what I'm seeing, and I shouldn't have this in there. So let me show you. Hopefully you can see that. But realistically, all I can see on these injectors is not even 1 millisecond of injection. So you know what, guys? I'm going to put a channel on the oscilloscope. And do this really quickly. So give me just 1 second, guys. I'm going to battery ground in here. If I can connect it properly. Okay, now I got it. I'm going to put one injector, either bangle. It looks like they're doing the same. This is a little probably too far away for you guys. And I'm going to put this onto the automotive picoscope. Because I have now 2 picos in here. Give me 1 second to activate that one. All right, so I'm going to keep this in here because look, we have 2.9 milliseconds of injection. Let's open Pico Automotive, which is right here. Let me get you to see that. And I have, like I said, only one channel in there. Oh yeah, this is what is happening. Let me turn this channel off because we're not using it. We're going to go down to milliseconds of injection. Let's put a trigger in there. An automatic trigger just to stop that from walking in the screen. But yeah, this is definitely a big problem on this computer. Now I'm even better, more information for all of us. So I'm going to save this data onto his folder. Let's see right here. And I'm just going to put injector in injector bank 1. Even though bank 1 and 2 look the same, running at 4,000 RPMs. And I'm gonna say, well, now I can revisit that information. But yeah, I mean, look at this, guys. This is like a multi-strike injector that does not exist, by the way, right? I'm just putting a name in there for what we're seeing in here. This is very, very glitchy. And I have seen, some of these computers do something like this. I'm going to reduce the view. You can do the display up or down, and this is going to make that image a little smaller. So we can have those values that you guys see on the bottom and then the rest on the top. But yeah, so as you see, this is like a multi-strike. So the computer is trying to command this injector for 2.9 milliseconds. I will probably go up to there. You see 2.9. Like that's around 2.9. But the reality, and this is why my simulator right here is very, very exact, very good to show things like that to me. This is a very fast capture simulator that is showing me that it's not realistically 2.9 milliseconds. Why? Because that's the reality here. That the on time, remember, on an injector will be the bottom. So let's say, this injector is probably on, and then it releases it for like a 1.3 milliseconds. But then it creates a glitch. Why? Because then it's off again for all this time, almost 1 millisecond, 748 microseconds. So it's almost the same amount of time off, and then it comes back for like a very short period of time, which is this is going to be on the microseconds, 117 microseconds, then off again, and then on and off. This is a problem that glitch is doing. Yes, this has to be running so bad, no doubt about it. And let me connect to the other injector driver, right? So we have this in here. So I'm going to put it live so you can see when I'm unplugging this from here. So right now that should drop, and it did. And I'm going over to the order bank of injectors, and we can see that we have the exact same thing. So, and I didn't need, I'm just showing this because of course I'm gathering the data for Jake, and he's most likely going to send this to Bob and says like, well, thank you so much for all that you have done for us. And I'm just guesstimating here, but looking at what they have done, and I think that we might be on the right direction. But yeah, this is definitely a bad computer, no doubt about it. We have, and the problem is, and I understand where Jake and even the owner of the boat is like, well, I did all that damage on the other computer. Maybe I damaged something on the boat when I connect that backwards. And it could happen, right? I'm not saying that like the sensors that they replaced and the stuff like that they replaced and didn't need it to be replaced. Harness wise, it's good. But this computer is junk. This computer needs to be repaired if it's possible to repair it, because sometimes this glitch is like a computer that has run with bad grounds and it's cooked inside. And I've seen that multiple times. I think we can close this now. You've been using because no, thank you. Just close that. I hate that from, and I have I was watching a video from Luis Rosman today about their, he's a lot into the right to repair and protecting consumers from companies that are trying to, give you commercials or block the use of your tool. Let's say, Picoscope is not one of them. Picoscope is actually it's an open source and you can use it for a lot. And I really love Picoscope for the same reason. But there is a lot of companies now, like Snap-on and Hotel and other companies that are trying to lock your tool to a subscription. I'm like, and I always say that if you want to lock me to a subscription, give me two choices. One is if you buy the tool, tool is for you forever. If you don't want to do updates, that's up to you. You will not have the latest and greatest software, but that's up to me. But that's my tool. Or if you don't want to sell the tool and you just want to sell subscription, then we'll give the tool for free and let's charge for subscription. Why? Because then the tool will be always yours and you can charge me just for using it in a subscription. But if you're going to think in your mind that you can charge me for the tool and then lock me to your subscription, and I cannot use, if I'm not in your subscription, I cannot use that tool, I think they're going to be slowly, we will all agree that that is a ripoff, and we'll stop using all those companies. And we should do that all across the board. I mean, I'm sorry, but if I'm buying a tool, that tool is mine. Otherwise, don't sell the tool, right? But yeah, that's another thing to discuss later. All right, I think we have done a very thorough testing here. I'm going to show you what I have also in here, and this is my connections to the computer. This is for Jake and whoever is going to be looking at this video. Let's move some of the things in here. Yeah. So they can see that this is their computer. I am using the correct and specific IAC drivers and test simulations that I have. I also have in here, which I think I might be able to put yet. This is connected to the 5-volt reference and sensor ground. And we have the 5-volt reference and sensor ground because this is very important. When you're doing a test, that you check the sensor ground. When you're doing a test like this, use the sensor ground and the sensor 5 volts to see what is the reading. But yeah, so the 5 volts is good. Let's put that here. Yeah, I created a harness that I can use my Marine harness from ECM 555 into the MEFI 3s, and then I can do the test that I'm been showing you here. As far as the harness, all right, guys, I actually want to add this information, which I stopped the video just before, and I'm probably going to edit that as you will see shortly. But so let me get you to the screens. Let me minimize this, make sure we are there. And we're going to turn this off and this one on. And now you're seeing the screen. All right, so I'm going to open DIACOM. As I mentioned to you before, I have multiple captures through the years of me working with these computers. And I have now a calibration that, as you see here in the top, it says, the calibration is, we can see that is the same number as in Paragon Marine D5CE. That is exactly the same exact calibration. So let me make sure you guys are also seeing me. Uh, 1 second, guys, because something is not right. Let me open this in here. Let me get you to Sony 1. So let me fix this 1 second, guys, because for some reason my camera is not showing when I'm showing you the rest of the information. Circle only is present. Sometimes this happens. I don't know why. Only is selected right here. And I got it fixed, I think, now. All right, so let me lower this down and push you into the display. Yep. Okay. That was all I wanted to put myself in there, so you guys can see me while I'm talking and while I'm moving around, so you can see that it's actually live. All right. So, I can run this test. This was a test that I was doing into another computer, and this was in 2021. As you can see there, this is 4 years old recordings that I got in here, and it's the same as a MFE3 with a D5CE calibration 5.7 Bravo. Same thing that we have here. It's the same. As long as that D5CE is there, that means it's exactly the same calibration. So we're going to pretty much select the data that I have as before. Well, a little bit of a different temperature, but that will not affect nothing. Manifold pressure. Trying to put as much as I have in here. The most important one, and this is what I want to show, is the IAC. The desired IAC, and what this computer that I don't even remember. I haven't even recalled to see if the computer was working perfectly or not, because it's not really what I'm here. I'm not doing the diagnostics on that computer, but I want to show what we have here. So, right, let's pick up the throttle position. We got throttle, manifold pressure. Oh, the RPMs are important, so you guys can see at what RPMs I'm doing the test, right? So, and this, where is the bar? I lost the bar. Then I can move the calibration. All right, so that's a glitch in there because I don't see the bar. Oh, I can actually move it like this, but that is a little slow. I didn't see this before. It looked like I can change with the arrows on the top one by one, you see? But I need to have the whole bar. So let me close this again one more time. Well, actually, maybe I can open it here. So this is when you are in a calibration. And I'm glad this happens in here, because if you are a marine technician or a marina and you're seeing this, you run into this problem. I think the way you need to do is disable content help for magnifying operation first. Okay, let me see. Okay, now so you can just disable when the zoom is there, then you cannot use that. So this is the calibration that we have here. All right, this is what I was looking for to have. Like now, this is the entire calibration, so we can do the zoom, and let's select the same thing. So we're going to start in order. Let's put the engine speed. I'm going to move this a little higher, no matter what those values in here I never use for anything, so we got more room to put different beats on zoom. So we got throttle and speed. We're going to put the manifold air pressure, a spark advance, which I also believe that other computer, Paragon computer, has problems with on the entire calibration. Injector milliseconds. I mean, we can, if you want, use the engine temperature, but realistically, for what we are going to see here, this is not going to change too much. Right, the main one right here is the desired IAC and the IAC position. So that's what we are. Just minimize that. Sometimes you don't grab it where you need it. Here's the ones that are, for me, the most important ones. We're going to, well, first roll this by itself. One thing that I want you to see immediately is the way this computer is acting. You see that the injector pulse width is very steady. The throttle position is very steady. The manifold pressure, the coolant temperature, you see there's no glitches. You can see one here and there, very normal in this. I mean, these computers are from 1999, right? So 25, 26-year-old computer. So that is not an uncommon thing to see, but here and there, you will probably feel something, but it will not affect the overall running condition on the boat. But that one, the Paragon Marine, I mean, that's unbelievable. So we can see how this one is running in idle and is running nice and smooth. It's not a problem. The IAC position is as desired. So that is there. So let's see when I do a change on RPMs. All right, so we went from 140 to 150. So immediately a change. And it has to be a change. It has to be a change. So I'm a little different on the manifold pressure compared to the values that I was using with Paragon Marine, but I tried different values of manifold pressure, throttle position, and it never changed. So let's keep going on here. So you see I'm 3600 RPM plus minus 3 RPM. That's not a big difference. Throttle position plus minus 0.02. That not a glitch. It's all good. All right, look at the IAC. So we went, and I'm going just to do this manually. So from 1800, so we went from 4,000 out of 150 steps, because that's what that is calling in here, steps. And then when I go down to 3,000, immediately goes down to 0. That's the desired IAC position. So the computer is shutting down the IAC so the engine doesn't stall. Right? So as I said, I am an expert on these computers. When I'm giving this information, and this is what I'm taking the time, and I know that I'm not getting the view that I should really, or I wish I can get, because that means that more technicians are using this information on a daily basis to really perform really good diagnostics. And I'm trying to promote more, and this is a free information that I'm trying to give away to all of those marine technicians and automotive technicians, because this is how you analyze data. Don't just go into a gut feeling and start spending people's money, because that is not fair. You need to analyze data, gather your data, save the data, mark it as known good, known bad, because sometimes you want to have bad to see how we'll react if something like that happens, because you're trying to correct something, so that might be a valuable information. So you can always use any information, pictures, data, save it. Look at here. This is 4 years old information, and I can show you how important it is to have that, because now with this, I can, with position, tell Paragon Marine 100% that that computer is no good. Is that a calibration problem? Is that a computer problem? I don't know, because I haven't even touched the computer internally to see how it is, but I tried to put all this information together for you and for them. All right, let's proceed with this calibration or these sets that I recorded. So as soon as I go down into 1400 or so, now we got 117 steps, and now the computer is open that IAC again to control, so the vehicle, the boat doesn't die, the engine doesn't die. 1800, we're going down in RPMs. I'm now steady in 1800. The desire and the IAC position have changed from 150 to 129. Sometimes it even wasn't 0, as I just showed you before. Whatever strategy the computer is using for that specific RPM. And in this time, the computer is very, very capable of control everything. Why? Because I can see that the throttle position is steady, the map manifold air pressure is steady, the coolant temperature sensor is steady. But when you have that glitch that goes up and down 200 RPMs or 20% on the throttle, the computer is like, okay, well, is somebody playing with the throttle, with the actuator? let's call it accelerator, right? It's somebody, is the person trying to do that. The logic of the computer doesn't understand what is happening. And sometimes it's just, okay, let me just wait for them to stop what they're doing so I can try to do a change. See where I'm going with that? All right, so let's keep going down to idle. Now we have 11 steps on the IAC. That is 100% different. And as soon as it goes into the normal RPM, now we have 102 steps. Why? Because yes, it's going to shut it down, shut the IAC off, so it's not a surge of air while you're decelerating. So as you're coming down and throttle, right? So it's going to shut the IAC to let the throttle take place or take command. And then as soon as I see that it has a steady RPM, boom, let's open that IAC with a full control. And then let's keep this engine into a smooth idle. And that's exactly what we can see here with no doubt. You see, this is now is completely in control. You can see how the spark advance also just changed too from -5. It was in here a +5, and then went to -5 when the throttle went to 0. You see, we got a moment in there. I don't know what I was doing, and I got the throttle into 0. But yeah, that's the response when I went to 0. But as soon as I change that from 0 to whatever I can do in there, and this is probably even a recorder from the boat. I'm not sure, when I got this recording. But yeah, we can see the response on the IAC. If the IAC see the throttle at 0%, it's open in 61 steps. Why? Because otherwise, if it's 0 throttle and it's 0 IAC, well, the engine will die, right? Makes sense, right? All right, so guys, I just want to add this information because I think it's very valuable with this. And I can see that I set another fault on the tab. It's probably going to be throttle position low because this went to 0. But I think that this is a very important information that I want to share. I'm probably going to, cut it and adjust it into the video so it's more into the correct position so you guys can see the entire video properly. Thank you so much. See you next time. Bye-bye.